Hi, welcome back to my class in Mathematics of Investment. Our lesson for today is also a topic in mathematics in the modern world. For today, we will take out equation of values. And you had your first encounter with equation probably in arithmetic. And we define equation as a mathematical statement that indicates equality between two quantities. And the equality is indicated by the equal sign. In an equation, the two quantities have to be similar because you cannot have an equality between two quantities that are not similar or dissimilar. An equation of value can be compared to a story that has two different sides. They say that a story has always two different sides, and that is true with an equation of value. An equation of value consists of two sides, the left-hand side and the right-hand side. But unlike in a story where the two sides may be different versions of the same story, in equation of values, the two sides have to be equal quantities. They have to be numerically equal quantities. And for our first example, consider the following problem. Mr. X has the following obligations. Letter A, 25,000 pesos due after a year without interest. Letter B, 56,000 pesos due after 2 years with 7% simple interest. And C, 78,000 pesos due at the end of 4.5 years with interest at 15.5% compounded quarterly. Find the single payment to settle all the obligations if Mr. X agrees at 12% compounded monthly. In the equation of values, the one side of the equation of values will consist of the maturity values, the sum of the maturity values of the obligations. And in this example, Mr. X has three obligations, but the first obligation of 25,000 pesos has no interest. So after 1 year, Mr. X will pay the same amount of 25,000 pesos because 25,000 pesos has no interest. The second obligation is due after 2 years, but this loan or obligation of 56,000 pesos has an interest of 7% simple interest. That means we have to find the maturity value or the accumulated value of 56,000 pesos after 2 years using the formula for accumulated value at simple interest rate, which is given by capital A equals P times quantity 1 plus IT, where the small I is the simple interest rate 7% in decimal number, and T is 2 years, and capital P, the principal, is 56,000 pesos. The third obligation of Mr. X is 78,000 pesos due at the end of 4.5 years or 4.5 years with interest at 15.5% compounded quarterly. The same way, the second obligation, we have to find the maturity value or accumulated value of the third loan or obligation of 78,000 pesos at the end of 4.5 years or 4.5 years. But in the third obligation, the interest is at 15.5% compounded quarterly, which means that the interest on the loan of 78,000 pesos will be computed 4 times a year every 3 months. And so to find the maturity value or accumulated value of the third obligation worth 78,000 pesos, we have to use the formula for accumulated value at compound interest rate denoted by capital A and is equal to P times quantity 1 plus I to the power n, where P is the principal, the original loan of 78,000 pesos, and small I is the compound interest rate 15.5% divided by the number of interest computations in a year, which is 4 as indicated by quarterly, and the exponent n is the number of interest computations for 4.5 years. After we have computed the maturity values of these three obligations, we add them and we equate them to the other side of the equation of values. And the other side of the equation of values consists of the payments. For this example, for this particular example, we are looking for a single payment that will settle all of these three obligations. And Mr. X agrees to pay an interest of 12% compounded monthly. And so, we will denote the single payment with a variable. We usually use X. To simplify the writing of the equation of values from which we will solve for X, which we denote as the amount of single payment that will settle all of these three obligations, we use a timeline. It's a horizontal line and denoted by T. Above the timeline, we write the maturity values of the obligations, and below the timeline, we write the payments. Again, in a timeline, we write the maturity values of the obligations above the timeline, and below the timeline, we write all the required payments. In this particular example, there is only one single payment required. Our timeline begins with 0, which indicates the time now or the time today. And from 0, we write 1, 2, 3, all the positive integers up to positive infinity. So 1 here would denote 1 year, 2 for 2 years, and so on. Now we write the maturity values of each of the three obligations. The first obligation of 25,000 pesos has no interest, without interest. And this obligation without interest is due after 1 year. So above the timeline, we write 25,000 pesos after 1 year for the maturity value of the first obligation. The maturity value of the first obligation is the same as the original amount of loan or principal, 25,000 pesos, because it has no interest. Next, we compute the maturity value of the second obligation or second loan of 56,000 pesos, which is due after 2 years, but this time there is an interest of 7% simple interest. And we compute the accumulated value of 56,000 pesos using the formula for simple interest rate. At simple interest rate, the accumulated value denoted by capital A is given by P, principal, multiplied by quantity 1 plus IT. In the second obligation, the principal P is 56,000 pesos. P equals 56,000 pesos. Small I here is the simple interest of 7%. And we convert the interest rate in decimal number, 7%, divide by 100 is 0.07. And the loan with interest is due after 2 years. Therefore, T is equal to 2. And we substitute the values of P, I, and T into this formula to compute for the accumulated value or maturity value of 56,000 pesos after 2 years. A is now equal to 56,000 pesos multiplied by quantity 1 plus I 0.07 multiplied by T 2 years. And when you compute this in your calculator, you start with 0.07 multiplied by 2 plus 1 equals, and the answer multiplied by 56,000 pesos. Again, you start with 2 multiplied by 0.07 plus 1, and you press the equal sign in your calculator, and the answer should be 1.14, and multiply that by 56,000 pesos. And you should get 63,000 pesos 840. $63,000 840 is the maturity value or accumulated value of the original loan or the second obligation worth 56,000 pesos. In the timeline, we write 63,000 pesos 840 at the end of 2 years. Now we have written the maturity values of 2 obligations. The first obligation is worth 25,000 pesos and it's already the maturity value of 25,000 pesos because it has no interest. The second obligation of 56,000 pesos has a maturity value of 63,840 pesos, and this amount, including the principal and interest, is due to be paid at the end of 2 years. Next, we will compute the maturity value of 78,000 pesos to be paid at the end of 4.5 years. But this time the interest is computed at 15.5% compounded quarterly. Now compute the maturity value of the third obligation or the third loan worth 78,000 pesos due at the end of 4.5 years with interest at 15.5% compounded quarterly. And this is the formula to compute the accumulated value or maturity value of a principal at compound interest rate, denoted by capital A. Maturity value is equal to principal multiplied by quantity 1 plus I to the power n, where I is equal to the interest rate per year divided by the number of interest computations, or J is the compound interest rate given. And the compound interest rate given is 15.5%. And 1/2 is 0.5 plus 15 is 15.5. And 15.5 is still in percentage, so we divide it by 100. 15.5 divided by 100 is 0.155. And so the interest rate per 3 months, in this example, in this third obligation, the interest will be computed every 3 months. And the interest rate every 3 months is the compound interest rate J divided by the number of interest computations in 1 year, which is 4. Because the problem says the given interest rate of 15.5% is compounded quarterly, which means that M is equal to 4. That means interest will be computed 4 times in a year every 3 months. and small I is equal to 0.55, the compound interest rate, divided by M is 4. You may leave this as is, 0.155 divided by 4, and substitute this direct into this formula, or you may write this, convert this to decimal number. 0.155 divided by 4 is 0.03875. But if you convert this to decimal places, to decimal number, you have to take all the decimal places, because we will only round off to 2 decimal places in the final answer. And M is 4. As I said, the compound interest is compounded quarterly. That means interest is computed 4 times in a year. And the third obligation is worth 78,000 pesos. So we now compute A, the maturity value or accumulated value of this third obligation, 78,000 pesos. The exponent n here is the number of times that interest will be computed over 4.5 years. The loan with interest is due at the end of 4.5 years. And in 4.5 years, the interest will be computed m multiplied by t, the number of interest computations in 1 year multiplied by number of years. And for this example, m is equal to 4, that is, interest will be computed 4 times in a year, and the obligation is to be paid at the end of 4.5 years. P is 4.5 multiplied by 4, you should get 18. Now we compute this using our calculator. You start with the quantity inside 1 plus 0.03875. 1 plus 0.03875, and you raise that sum to the power 18, and you press the equal sign in your calculator, and you should get 1.98243365645, and that answer multiplied by 78,000 pesos. And you should get 154,629, and the answer in your calculator, you round off to 2 decimal places. And this is now the final answer for the accumulated value, so we will now round this off to 2 decimal places. And you should get 154,629.83 pesos. This maturity value of the third loan or obligation, we write above the timeline at the end of 4.5 years. And this is 4 years. Between 4 and 5 is exactly between 4 and 5 is 4.5 years. We now all have the maturity values of the 3 obligations above the timeline. The first obligation is due at the end of 1 year, and the amount to be paid is 25,000 pesos, the same as the original loan of 25,000 pesos because it has no interest. The second obligation of 56,000 pesos is due or to be paid at the end of 2 years, and the amount to be paid including principal and interest is 63,840 pesos. And the third obligation, which we have just computed, has a maturity value of 154,629.83 pesos, due to be paid at the end of 4.5 years. After you have written all the maturity values of the obligations, you now write the payments below the timeline. And there is only one payment, there is only single payment to be found for this example. And the single payment is to be paid at the end of some year. If you notice in the given problem, it is not given when the single payment is to be made, but it is usually the borrower who will tell the bank when he wants to settle the obligations. Now, for this particular example, we assume that Mr. X would like to pay the single payment to settle all the 3 obligations at the end of 3 years. So we let X be the single payment to be made at the end of 3 years, if that is the wish of Mr. X to settle all the 3 obligations. But Mr. X agrees to pay an interest of 12% compounded monthly. And below the timeline, we write X, the amount of single payment at the end of 3 years. The single payment is to be made at the end of 3 years. And with this payment, all the 3 obligations will be cancelled. And we want to find the amount of this single payment at the end of 3 years. The next step is to select a comparison date. That is, we will find all the values of the maturity values of the 3 obligations at the comparison date, and we will also find the value of the single payment at the comparison date. That is, all the values of the 3 obligations, the sum of the values of the 3 obligations at the comparison date should be equal to the amount of the single payment at the comparison date. And the comparison date can be any time in the timeline. It can be 0, 1 year, 2 year, 3 years, 4 years, 5 years, etc. The comparison date can be any point in the timeline, can be any time in the timeline denoted by T. But in most cases, the comparison date is selected where one of the maturity values is located, or where one of the payments, if there is more than one payments to be made, is located, because that will simplify the solution of the equation of values. Now suppose I will select 2 as the comparison date. But as I said, any number, any point in this timeline can be chosen as the comparison date. And we will find now, we have selected 2, the end of 2 years as the comparison date. It's called comparison date because we will compare the sum of the values of the maturity values of the obligations at the comparison date and with the value of the single payment at the comparison date. That is, the sum of the values of the maturity values of the obligations at the comparison date, we will equate to the value of the single payment at the same comparison date. And the interest that we will use is the interest rate that Mr. X has agreed with the bank, which is 12% compounded monthly. because the interest rate that Mr. X agrees with the bank to settle all the obligations is a compound interest rate, we will use this formula to find the accumulated value or the maturity values of these amounts at the comparison date. You can see that the second obligation is already at the comparison date. So we will not find the accumulated value of 63,840 pesos. The value of 63,840 pesos at the comparison date is equal to itself, 63,840. But the first obligation with maturity value of 25,000 pesos, we have to find its value at the end of 2 years. That means we have to accumulate or find the accumulated value of 25,000 pesos at the end of 2 years. If we want to accumulate or find the accumulated value of 25,000 pesos at the end of 2 years, we take 25,000 pesos in this formula as the principal P. And the interest rate per month is given by J over M, where J is the given compound interest rate, 12%. Divided by 100 is 0.12. And the compound interest rate of 12% is compounded monthly, which means M is equal to 12. That is, the interest will be computed monthly. Therefore, the interest rate per month, is equal to J divided by M, where J in decimal number is 0.12. And M is 12. Interest is computed 12 times in a year. So we divide 0.12 by 12 using our calculator. Point 12 divided by 12 is 0.1. Sorry, 0.01. Let us check again. 0.12 divided by 12 is 0.01. So we now find the accumulated value of 25,000 pesos using this formula. P is 25,000 pesos. Multiplied by 1 plus I is 0.01 to the power N. N is equal to M multiplied by T, where M is 12, interest is computed 12 times a year, and T is the number of years that we want to accumulate 25,000 pesos. From 1 to 2 years, the time elapsed is only 1 year. That is, T is 2 minus 1. That means we will accumulate 25,000 pesos for only 1 year. Again, from 1 to 2, the time is 1 year. That is 2 minus 1. And N is equal to M, 12 multiplied by T, 1 year. Or 12. We now compute this value using our calculator. Again, you start with 1 plus 0.01 equals, and raise the answer to 12. Press equals and multiply the answer by 25,000 pesos. 1 plus 0.01, press equals, you get 1.01, and that answer you raise to the power 12. And you should get 1.12 682503013, and that answer multiplied by 25,000 pesos. And this is now the final answer, so we round it off to 2 decimal places, and you should get 28,170.63 pesos. And that is the value of 25,000 pesos at the comparison date. The value of 25,000 pesos after 1 year or at the comparison date 2 is 28,170.63. That's for the first obligation. For the second obligation, the second obligation has a maturity value of 63,840 pesos, and this is to be paid at the end of 2 years. Since 63,840 pesos is already at the comparison date, we will not accumulate it anymore. The value of this, the maturity value of the second obligation, 63,840 has the same value at the comparison date. Now, the third obligation is to be paid at the end of 3 years. The third obligation is to be paid at the end of 4.5 years. And the maturity value of the third obligation to be paid at the end of 4.5 years is 154,629.83 pesos. And we will find the value of this at the comparison date. Hence, from 4.5 years, we find its value. We are going back in time. We will find the value of 154,629.83 pesos at an earlier date, which is 2 years. And to find the value of 154,629.83 pesos at an earlier date is to discount this amount, which means that we have to find the present value, the value at an earlier date of 154,629.83 pesos. And to find the value of this at an earlier date is to discount 154,629.83. And to discount is to find its present value denoted by P. And the time elapsed from 2 to 4.5 years is 4.5 minus 2 is 2.5 years. Which means that we have to discount 154,629.83 pesos for 2.5 years. And again, to discount is to find its present value or to find P with accumulated value of 154,629.83. And we will solve for P from this equation or formula for accumulated value of P or principal. We continue, we now find the value of the maturity value of the third obligation. The third obligation has a maturity value of 154,629.83 pesos to be paid at the end of 4.5 years. And the comparison date that we have chosen is 2. which is a time before the due date for the payment of this maturity value of 154,629.83 pesos. That means we have to find the value of this maturity value of the third obligation at a time, at an earlier time, at a time earlier than 4.5 years. And when you find the value of an amount at an earlier date, that means that you want to discount it. To find the value of 154,629.83 pesos at an earlier date is to discount 154,629.83. And to discount an amount is to find its present value, denoted by P. Or we want to find the principal P whose accumulated value is equal to 154,629.83. And to discount this amount at an earlier date, or to find the present value of 154,629.83 at the beginning of 2 years is to find the P using the interest rate that Mr. X has agreed with the bank, which is 12% compounded monthly. From this formula, we solve for P. So we want P to be the only variable at one side of the equation. And to solve for P, we divide both sides of this equation by quantity 1 plus I to the power n. And 1 plus I to the power n divided by 1 plus I to the power n is equal to 1. Or you simply cancel this out. And you get P is equal to A divided by 1 plus I to the power n. But using a property of exponent from your algebra course, we can take this to the numerator, and when you do that, you take the opposite sign of the exponent n. So if you bring 1 plus I to the power n to the numerator, you will get 1 plus I raised to negative n. Therefore, P is equal to A times quantity 1 plus I to the power negative n. And this is the formula that you will use whenever you want to find the value of an amount at an earlier date, or whenever you want to discount an amount, that is, you want to find its present value at an earlier date. That means you solve for P, and this is the formula that you will use. P, present value, or P is the principal of that whose accumulated value is equal to 154,629.83. In general, P, present value of an amount, is equal to its accumulated value times quantity 1 plus I to the negative n. Since we want to find the present value of 154,629.83, we take this amount as your A. The accumulated value of the amount P we want to find at an earlier date. And the interest rate I is the same. J divided by M, 0.12 is the compound interest rate. The interest rate that Mr. X agrees with the bank. Compounded monthly, M is 12. Interest will be computed 12 times a year. So the interest rate per month is 0.01. But we have to compute for N. N is given by MT. And M is 12. The interest rate, compound interest rate is compounded monthly. M is 12. But the time T is 2.5 because we want to discount 629.83 pesos for 2.5 years. That is the time from 2 to 4.5 years is 2.5 years. 2.5 is equal to 4.5 minus 2 equals 2.5. So we will discount this maturity value of the third obligation for 2.5 years. That is, we will find the value of this amount 2.5 years earlier. And we take P equals 2.5 multiplied by M, 12. And we compute that using our calculator. We have 12 multiplied by 2.5. And you should get 30. We substitute A is 154,000. $629.83 multiplied by quantity 1 plus I, where I is 0.01 to the power negative n, where n is 30. And we compute this value in our scientific calculator. Again, we start with 1 plus 0.01, press equals, and the answer you raise to the power negative 30, press equals, and the answer multiplied by 154,629.83. We have 1 plus 0.01, press equals, we get 1.01, and that answer you raise to the power negative 30. Press equal, and the answer in your calculator multiply by 154,629.83. And you should get 114,723. $114,723.41 pesos is the discounted amount of 154,629.83, or 114,723.41 is the present value of 154,629.83. And if you want to check, you accumulate 114,723.41 using this formula. Accumulate this amount for 2.5 years using this formula, 12% compounded monthly, and you should get 154,629.83. This 114,723.41 is the value of this amount at an earlier date. two and a half years, 2.5 years earlier, and that is at the comparison date. Now we have all the values of the obligations at the comparison date. The value of the first obligation with maturity value of 25,000 pesos at comparison date of 2 is 28,170.63. The value of the second obligation with maturity value of 63,840 is equal to itself because this maturity value of the second obligation is already at the comparison date. So the second obligation value at the comparison date is 63,840 pesos. And the third obligation with maturity value of 154,629.83 pesos at the comparison date, which we obtained by discounting or by getting the present value of 154,629.83 at the comparison date by discounting this amount for 2.5 years using this formula is 114,723.41. Now we find the value of the single payment at the comparison date. And the comparison date is a time earlier than 3 years. So that means to find the value of X at the comparison date, we will also find the present value of X, the single payment at the end at the comparison date of 2 years. And to find the value of X at an earlier date, as what we did in the third obligation, is to discount the single payment for how many years? 3 minus 2, or 1 year. So to find the value of the single payment at the comparison date 2 years, we will discount the single payment for 1 year. 1 year is 3 minus 2. Or we will find the present value of X at the comparison date by discounting X for 1 year using this formula. To find the present value of X, we use this formula. And we take A as X. And I is the same 0.01 equal to J divided by M. The given compound interest rate that Mr. X agrees with the bank is 12%, compounded monthly. So I is 0.01, but N here will change because we are discounting X for only 1 year. So N here will be M multiplied by T, where M is 12 and T is 1. And we substitute those values into this formula to find the present value of the single payment X. We now find the present value or discounted amount of the single payment X. We discount it for 1 year. 3 minus 2 is 1. And we find to discount X for 1 year is to find its present value. Using this formula, P equals A times quantity 1 plus I to the negative N, where we take A is equal to X, and I, as we have earlier, I is 0.01, the interest rate per month, equal to J over M, where J is the given compound interest rate of 12%, which Mr. X agrees with the bank, compounded monthly. So 0.12 divided by 12 is 0.01, but N will change because we discount the single payment X for only 1 year. And N is equal to M multiplied by T. The number of interest rate computations for 1 year is 12. And we discount X for 1 year, so N is equal to 12. Multiplied by 1 is 12. We now substitute these values into this formula. We get P is equal to A X times 1 plus I, 0.01. 0.01 or 0.01. to the power negative n, where n is 12. Now, you can only compute this value in your calculator. And when you compute this value in your calculator, just multiply it by x. We compute this using our calculator. We have 1 plus 0.01 1 plus 0.01 1.01, and that answer you raise to the power negative 12. And the answer in your calculator, multiply it by x. Since this is not yet the final answer because we do not know the value of x, because x is what we are actually looking for, the single payment in this problem. So we get all the decimal numbers from your calculator and multiply that by x. And you should get 0.88744. 922,527. And this is the value of, multiply this by x. Using the calculator, 1 plus 0.01 to the negative 12 is 0.88744, 922,527, and multiply that by x. And this is the present value or the discounted amount of the single payment x at the end of the comparison date, or 2 years. Now we are ready to write the equation of values. For writing the equation of values, this is the sort of formula that you should follow. At one side of the equation, you should write the sum of the values of obligations at comparison date. This is actually the sum of the values of the maturity values of the obligations at comparison date. And in our example, the values of the maturity values of the obligations at comparison date are given by these amounts. 28,170.63 pesos is the value of the first obligation with maturity value of 25,000 pesos at the comparison date of 2 years. And when we find this, we use the compound interest rate of 12% compounded monthly. And the maturity value, the value of the second obligation, or the value of the maturity value of the second obligation, 63,000 is 63,840. And this is also the maturity value of the second obligation, and the value of that maturity value at the comparison date is equal to itself because this maturity value of the second obligation, as I said earlier, is already at the comparison date. And this amount of 114,723.41 pesos is the value of the maturity value of the third obligation at the comparison date of 2 years. And for the left-hand side of the equation of values, we will simply add these amounts. So this sum represents the left-hand side of the equation of values. It is the sum of the values of the maturity values of the obligations at the comparison date. And the comparison date that we have chosen for this example is 2 years. At the other side of the equation of values, we write the sum of the values of the payments at the same comparison date. And in this particular example, there is only a single payment. There is only one payment to make, which we denote by X. And the value of this single payment at the comparison date is 0.88744922527 multiplied by X. And we write this at the left-hand side of the equation of values. Now, it is easier now to solve for X, the single payment to be made to settle all the three obligations. From this equation, get the sum of the amounts at the left-hand side and then divide both sides by 0.8874492227 so that you will only have X at this side of the equation. First, we get the sum at the left-hand side using our calculator. We have 28,170.63 plus 63,840 plus 114,723.41. And you should get 206,734.04. I will write first the right-hand side of the equation because it is customary that we have the variable at the left-hand side of the equation. We have 0.88 Now, this equation is equivalent to this equation, except that I wrote this at the left-hand side because, as I said, it is customary that we have the variable at the left-hand side of the equation. And the sum at the left-hand side, I wrote at the right-hand side of this last equation. And from this equation, we can readily solve for X by dividing both sides by 0.887449222527. At the left-hand side, 0.88744922.527 over 0.88744922.527 will cancel out because it's equal to 1. And at the left-hand side, we only have x. At the right-hand side of the equation, you divide 206,734.04 by 0.88744922.527 and you round off your answer to 2 decimal places. We have 206,734.04. Divide that by 0.88,744,922.527. And you should get 232,953. The single payment to be made by Mr. X amounts to 232,953.09 pesos. The payment of this amount will settle all his 3 obligations. Again, to recap the process in solving equation of values, the first step is to write to find the maturity values of the given obligations. And then you plot these maturity values on a timeline above the timeline at their due dates. The second step is to identify the payments, and the payments are denoted by variables. If there is a single payment, then you use only one variable, and we write this variable representing the unknown single payment below the timeline. And you write the single payment at the due date, at the time where the single payment is to be made. In our example, the problem does not specify when the single payment is to be made, so I made an assumption that the single payment is to be made at the end of 3 years. So I placed X at the end of 3 years. And then step 2 is to decide to choose a comparison date. The comparison date is can be any year, any number on the timeline. And it is up to you to select the comparison date. But as I said earlier, it's easier to select a comparison date where you have one of the maturity values of the obligations, or where you have one of the payments to be made. Because if you select as what we did in our example, we have selected 2 years as the comparison date because the maturity value of the second obligation is already at that comparison date. And so we do not have to find its value at the comparison date by accumulating it or by discounting it. But you can select any other comparison date. And then step 3 is to find the values of the maturity values of the obligations at the comparison date by either accumulating or by discounting. And then you also find the value of the payments at the comparison date by either accumulating or discounting. And then step 4, you write the equation of values. At one side of the equation of values is the sum of the values of the maturity values at the comparison date. And when you get the values of the maturity values of the obligation at the comparison date, you use the given interest rate that has been agreed upon by the borrower and the bank. In our example, it is 12% compounded monthly. And the other side of the equation of value will be the sum of the values of the payments at the same comparison date. And after you have written the equation of values, you can readily solve for x from that equation of values. And that completes our solution for this first example for equation of values. For your practice, please try the following problem. Miss Y has the following obligations. A, 12,000 pesos due in 1.5 years or 1.5 years without interest. And B, 27,000 pesos due in 3.5 years or 3.5 years with 10% simple interest. Find the single payment at the end of 2.5 years or 2.5 years if Miss Y agrees at 9.5% compounded quarterly. In this problem, the single payment now is to be made at the end of 2.5 years. And you take any variable to represent the single payment. You can use X or Y or any other variable. And in the timeline, you write that variable at the end of 2.5 years. At the end of 2.5 years, below the timeline, you write X or Y or whatever variable you will choose to represent the single payment. And the first step is to find the maturity values of these two obligations at their due dates. The first obligation has no interest, but to be paid at the end of 1.5 years. The second obligation has an interest at 10% simple interest. And this amount together with interest is to be paid at the end of 3.5 years. So to find the maturity value of the second obligation, you use the formula for accumulated value of principal at simple interest. That is A equals P times quantity 1 plus IT. And then you plot these maturity values of these two obligations above the timeline at the end of 1.5 years and 3.5 years. And then you select a comparison date. And then you find the values of the maturity values of these two obligations at the comparison date that you will choose using this interest rate that Ms. Y has agreed with the bank, 9.5% compounded quarterly. And you also find the value of the single payment at your chosen comparison date using this amount, 9.5% compounded quarterly. And then you get the sum of the values of the maturity values of these two obligations at the comparison date. You get their sum and equate the sum to the value of the single payment at the same comparison date, and from that equation of value you solve for the single payment, which is represented by a variable that you will choose. And that completes our lesson for today. In the next lesson, we will take more examples for equation of values. If you have questions about the lesson today, you ask your questions in the comments below. But don't forget to subscribe to my YouTube channel, Art Calisan, the channel of learning and leisure. Thank you for joining me in my class today in Mathematics of Investment with topics that are also included in the course Mathematics in the Modern World.